you have seen. So to enable the halt mode, debug enable bit in NVIC register should be set. That is DHCSR register should be set. Right? And this bit can only be programmed using DAP, debug access port. So this cannot be set without a debugger. Debugger is very essential for that. And after enabling the debug mode, if you want to halt the processor, you need to actually make this bit as set, C halt bit. So if you are making the C halt bit as set, processor will go to halt mode. So this is how you are manually halting the processor by using C halt bit in the same DHCSR. Right. So this bit can be set either by the debugger or by the user program. That is how you are manually halting the processor. But if you want to make this thing to work, debug enable bit should be set. Then only the C halt bit will be causing the processor to halt itself. Right. And I have already told that the bit definition of this DHCSR will depends on the or differs in the both read and write operation. In the case of write operation, you need to give debug key in these bits. So this is a debug key A05F. Then only you will be given permission to write into these bits. Debug enable, C halt, C step, etc. But for read operation, this key is not required. And from where you can read? From the higher half word, 16 to 25. You can read the status bits. Each of these are status bits. So this bit shows that core has been reset. This shows that instruction is completed since the last read. Then it shows that the processor is lock up, sleep mode, processor is halted, and the last one, register ready, shows that the read or write operation is completed while reading or writing the debug registers that we will see later. So these are the bits present in debug halting control and status register, DHCSR. Then the next mode is debug monitor mode. So for configuring that, you are having another register known as DMCR, debug exception monitor control register. DMCR. The other one was DHCSR. This is DMCR, debug exception monitor control register. In that, there is a bit known as monitor enable. If this bit is set, then only your debug monitor exception will be enabled. Similarly, how will you enable the halt mode? Debug enable bit should be set, C_debug. Here, for enabling the debug monitor exception, monitor_enable bit should be set. Right. Then for enabling the trace system such as DWD, DWT, ETM and ITM, these are the three trace units. If you want to enable these trace units or trace system, trace enable bit also should be set. Right, because I told debug monitor mode is nothing but an exception like the other exceptions. Right. So if this exception has to be generated from these trace modules, trace enable bit also should be set. Right. Then here there is another feature known as vector catch, VC. So what do you mean by vector catch? And this will be applicable only in the halt mode debugging. And what do you mean by vector catch? When a fault or a core reset take place and corresponding control bit is set, it will halt the processor, and processor will halt as soon as the current instruction execution is completed. That means whenever a particular fault is occurring, it will halt the processor and corresponding vector address will be taken. Or whenever a fault is occurring, it will halt the processor. That is known as vector catch. So here you can see this is a trace enable bit, this is a monitor enable bit, And these are the vector catch bits. So vector hard error, what does it mean? It will halt the processor whenever a hard fault is detected. It will halt the processor whenever an interrupt service routine is generating some errors. Then bus error means it will halt the processor when bus fault is occurring. Then status error means usage fault state errors is occurring. Similarly, check error means we have seen usage fault can also be occurred whenever some unaligned memory transfer is occurring and divide by 0 is occurring. So during this time, this bit will be set or the processor will be halted if this bit is set. Here the processor will be halted while usage fault, and it is dedicated for the coprocessor instruction. When you are trying to execute coprocessor instruction, it will halt the processor. Similarly, this is for memory management fault. This is for core reset. So these are known as the vector catches. So if you are setting the corresponding vector catch and debug monitor exception is occurring, it will halt the processor on corresponding vector catches. Say if I am making this bit as 1, whenever hard fault is occurring, it will halt the processor like that. So these are known as vector catches. So whenever fault is occurring and the corresponding control bit is set. If I have set this bit and if hard fault is occurring, it will halt the processor once the current instruction is completed its execution. So this is for halting the processor based on corresponding fault. And here you can see that these vector catch bits, these can only be reset on power on reset. These vector catch bit and also the trace enable bit. These bits, vector catch as well as trace enable bit, these can only be reset on power on reset. System reset will not reset these bits. But the monitor bits, which is starting with the monitor underscore these bits, debug monitor bits, these bits can be reset by power on reset and by system reset. Both can reset this. So what is monitor enable? It is used for enabling the debug monitor. Then what is monitor underscore request? This bit is used for manually entering into debug monitor mode. Which is a bit used for manually halting the processor? C halt bit. So similarly here also there is a particular bit. If you are setting that bit, debug monitor exception will be executed based on the current priority of the exception. Which is that bit? Monitor underscore request. The monitor underscore request is used for manually taking the processor into debug monitor exception. So these are the two modes and these are the two registers controlling both the modes of operation, that is halt mode and debug monitor mode. This is a flowchart showing what are the possible debug events which can create a halt mode. The first one is you can manually take the processor to halt mode. How will you do that? By setting C halt bit. But the processor will only move on to halt mode if C underscore debug enable bit is set. This is used for enabling the halt mode or enabling the debug mode. If this bit is not set, what will happen? Processor won't go to halt mode. It will ignore this. So whatever debug events has been occurring, this bit should be set. Then similarly, if a watch point is generated from DWT trace unit and debug event debug enable bit is set, again it will go to halt. So same thing will happen in the case of breakpoint instruction from flash patch and breakpoint unit. Similarly for vector catches, any one of the vector catch event is occurring and debug enable bit is 1, it will halt the process. The next one is external debug request. There is a pin known as there is a bit known as EDG request, that is external debug request, that is generated from other debug components, or from, if it is a multiprocessor system, it will be from another processor. So this will be given from other debug components or from another processor in the case of a multiprocessor system. So if this is set and debug enable is set, then the processor will also go to halt mode. Then the last one is execution of breakpoint. So if debug enable bit is set, it will go to halt. If it is not set, what will happen? It will check for these two conditions. Whether monitor enable is on. Monitor enable means whether debug monitor exception is enabled. If it is enabled, it will generate debug monitor exception. But if it is disabled and C debug is disabled, when both are disabled, it will generate a hard fault. So either debug enable bit or monitor enable bit should be set. So if debug enable bit is set, it will halt the processor, or it will execute the halt mode of operation. If monitor enable bit is set, it will execute debug monitor exception. If both are cleared, it will execute, or it will take the processor to hard fault. That is only in the case of breakpoint, not in the case of others. This is only related to the breakpoint. So breakpoint can take the processor either to halt mode of operation while performing debugging, or it can execute a debug monitor exception based on these two bits, debug enable or monitor enable bits. Right. So monitor enable bit is just we have seen it is there in DMCR bit. So this is what I told. External debug request can be generated from additional debug components, or it can be generated from another processor in the case of multiprocessor system. Right. Then after the debugging is completed, how will you bring back the processor to bring back the processor to the active mode from the debug mode? How will you take the processor? C halt bit should be cleared. So whenever C halt bit is cleared, processor will come out of the debug mode. So C halt bit can be cleared either in the software or by the debugger. So next one, this is a flowchart showing the debug events for debug monitor mode. So similar to the halt mode, if you want to take the processor to debug monitor exception manually, you can make monitor underscore request bit as set. This is used for manual setting. And I told the debug monitor exception is nothing but a normal exception. So if monitor enable bit is 1 and debug monitor exception is having same or lower priority than the current exception exception that is being executed, debug monitor exception will be pended, because processor is executing something else which is having higher priority than the debug monitor exception. But if the monitor enable bit is 1, because debug monitor is enabled, and this exception is having higher priority than the current process which is getting executed, what will happen? Debug monitor will be invoked, execution handler will be invoked. So debug monitor exception is nothing but it is same as other exceptions. So this will only execute if the processor is executing something else which is having lower priority than the debug, right? If it is executing anything else which is having higher priority than the debug monitor exception, then the debug monitor exception will be taken to the pended state. And once that the first process is completed, this will resume. Then similar to the halt mode, if a watch point event is generated from DWT and monitor enable bit is 1, and if the priority is having higher priority, then debug monitor will be executed. Otherwise, it will be ignored. Then similarly for the breakpoint, for the external debug request, also. Then for the execution of breakpoint instruction also. If monitor enable is 0, it will be ignored. Right? And if monitor enable is 0 and it is having lower priority than the current interrupt, what will happen? In the case of breakpoint, fault exception will be generated. Right? That fault exception is generated due to the breakpoint. So in the case of monitor request alone, the debug monitor exception will be pended if any other higher priority interrupt is executing. But in all these cases, it will be ignored if something else is getting executed. So this is what I told. It is just one type of exception. So it will be affected by the current priority of the processor. Okay. And once the debugging is completed, program execution will be returned to normal in the same case as you have seen in the exception return. So it is same as any other exception. So after the debugging is completed, it will come back, processor will come back to actual code as same as that is carried out in a normal exception. So normal exception return will happen. What are the different types of breakpoints available in Cortex M3? Two types of breakpoints are there. One is known as breakpoint can be executed by using breakpoint instruction or by using address comparators in flash, patch and breakpoint. Okay. So first one is breakpoint instruction. So breakpoint instruction is something like this: BKPT hash 8-bit immediate value. So it is a 16-bit thumb instruction, and the lower bits are nothing but the immediate data that is given to the following instruction. The immediate data that is given to the following instruction using breakpoint instruction. So when the processor is executed, when this instruction is executed, it will generate a debug event and can halt the processor core if C debug enable bit is set. Or it can trigger a debug monitor exception if monitor enable is set. That is what we have seen here while seeing the breakpoint. If debug enable is set, it will halt the processor. If monitor enable is set, it will execute debug monitor exception. Right. So if this is set, it will halt the processor. If monitor enable is set, it will debug. It will execute the debug monitor exception. So that is what is told here. Once the debug monitor exception is over, normally what will happen? It will return to the next address, whatever exception it may be. After execution of the interrupt or exception, the processor will come back to the next instruction, or the program counter will point to the next instruction. But in the case of breakpoint, it is not like that. Processor will return back to the same address of breakpoint instruction, not the address after that. Why? Because when you are using a breakpoint instruction, your normal instruction will be replaced by the breakpoint instruction. When you are using a breakpoint, what you are doing is, whatever instruction was present there previously, that will be replaced by the breakpoint instruction. Right? So after executing the breakpoint instruction, it will come back to the same address, so that the actual instruction will get executed. That is one of the small difference here. And the remaining instructions or the memory location remains unchanged. Only wherever you are using a breakpoint, that instruction will be replaced by the breakpoint. So after executing the breakpoint, that is whether halting the processor or debug monitor exception, it will come back to the same address, not to the next address. So that previous instruction will be executed. Normal instruction will be executed. And if breakpoint is instruction executed, but let us take debug enable and monitor enable is 0, then what will happen? Debug enable is 0 and monitor enable is 0. These two are 0. What will happen? It will execute hard fault. When both are 0, it will execute hard fault. That is told here. Both are 0, it will execute hard fault exception. And for identifying the hard fault exception has been occurred due to breakpoint, two bits also will be set. One is known as debug event bit, that is present in hard fault status register, and another one is BKPT bit present in default debug fault status register. So these two bits also will be set, because otherwise you will not be able to identify what type of event has occurred the halt has generated the hard fault. The hard fault will be generated due to many reasons. If any fault handler is not available or cannot be accessed, again hard fault will be detected, right? So in order to identify the hard fault exception has been occurred due to breakpoint, these two bits will be set automatically. Debug event bit in hard fault status and BKPT bit in default debug fault status register. Then breakpoint can also be used generated using address comparators in the flash patch and breakpoint unit. Certain address can be given in the address comparator, and whenever that address is reached, breakpoint will